Hi, my name is Jing. As a system architect, I designed a structural blueprint to ensure safe, deadlock-free concurrency. First, for system design, our system utilizes a clean, no-coupling 4-layer architecture. Control flows down from thread management through our synchronization engine into the file access layer and finally to the shared resource, all observed by a cross-cutting logging subsystem. Second, to guarantee synchronization correctness, we implemented the first reader-writer's logic using 3 core primitives: a read count integer, a mutex to eliminate counter race condition, and a write semaphore to enforce exclusive access for writers. Deadlock is prevented by enforcing a strict uniform log accusation order. Finally, for our advanced feature, we address the fatal flaw of reader preference starvation. We introduce a fairness turnstile binary semaphore. This forces incoming threads into bounded FIFO queue, ensuring waiting writers are never starved by an endless stream of readers. Thank you.
My role was implementing the reader and the writer threads using 4-6p threads. For the reader threads, multiple readers can access the shared resource concurrently. The first reader acquired the WRT semaphores to block the writers, while the last reader released it after the finishing. For the writer thread, the writer must acquire the WRT semaphore before accessing the shared resource, ensuring the exclusive access. This prevents the reader and the other writer from accessing the resource at the same time, that maintaining the data consistency and preventing the rest condition.
Hi, I'm Azmir, the tester and documentation lead. As tester, I designed 9 test scenarios, executed tests, captured log, and validate correctness. And documentation lead, I compiled the final report and prepared this presentation. My testing focused on correctness, concurrency, exclusion, and fairness. Next slide, about test scenarios and implementation. I designed 9 test scenarios covering single and multiple readers, multiple writers, mixed access, and stress testing. For fairness, I test both the basic reader preferring protocol and the basic fairness turnstile. Okay, next slide, the test result and validation. All 9 tests pass. The results show all 5 readers access concurrently. Writers were blocked until readers finish. The writers executed exclusively, incrementing the value from 1 to 3. The final value is 3, proving all writes succeed and data integrity was maintained. In conclusion, our system is correct, thread safe, and fair. Thank you.
When a reader wants to access the shared data, it first log the mutex and increment read count. If it is the first reader, it logs the WRT semaphore so that writer cannot enter. After reading, the reader logs the mutex again, increase read count, and if it is the last reader, it releases the WRT semaphore. The writer protocol is simpler. The writer waits for the WRT semaphore. If reader or another writer are using the resource, it waits. There are 3 important synchronization components. First is the mutex, which protects the read count variable so only one reader can update it at a time. Second is the WRT semaphore, which gives writer exclusive access to the shared resource. Third is the read count variable that keeps track of how many readers are currently accessing the resources.